Okay, so we have this interesting exponential equation here. We have x raised to the power log x base 2 divided by x raised to the power 2, everything equal to 8. Now, we could start by rewriting the left-hand side following the law of indices. So, this particular law of indices, when you have x raised to the power a divided by x raised to the power b, the bases being the same, you are picking one of the bases and then you're subtracting the power because it's division. So, we're going to follow the same logic here. We'll pick one of the bases and then we'll subtract the powers. The power for the first one here is log x base 2, and the second one down here, the power is 2. So we're going to write x raised by log x base 2 minus 2. So let's do that. So rewriting the left hand side, I'll have x raised to power log x base 2 then minus 2 following law of indices. Remember, I'm picking one of the bases and then subtracting the power log x base 2 minus 2, which I've just done here. Then everything equal to 8. And the next thing is to log both sides. But if I'm logging both sides, I will apply log to the base 2 to both sides because I have a particular term here written as log x base 2. So I'm going to apply log base 2 to both sides. So log base 2, and then I have this whole term, log x base 2 minus 2 equals to, I'm doing that to the right hand side also, log base 2, then I have 8. And of course, in following one of the laws of logarithm, the power for the number x, or for the value x, here moves over to the left side of the log to be in product with the log. So rewriting this, the whole power, which is log x base 2 minus 2, comes over to this side. You now have log x base 2 minus 2 times the log x base 2, then equal to, I can write this one as log, it can now be written as 2 raised to the power 3, then base 2. And I can open the brackets. I can just use log x base 2 to multiply every term in the bracket to open the bracket. So, and of course, this 3 can move over here also. So let's do this one first. Log x base 2 times log x base 2 gives me log x base 2, everything squared, then plus times minus minus, then log x base 2 times 2 gives me 2 log x base 2, then equal to, of course, this 3 comes over to this side to be in product with the log 2 base 2. And of course, when the number and the base are the same, we have 1. So this alone here gives me 1. If I evaluate this, then 1 times 3 gives me 3. So I'll just have 3 here left on the right hand side. Then equal to, of course, 2 log x base 2, then minus log x base 2, everything squared. Then notice that I have log x base 2 common on the left hand side, so I can replace it with a letter. I can say let log x base 2 be p. So I'm fixing p here. This one now becomes p squared minus 2p equals 3. So let's do that right away. So I have it as, so rewriting this one, and I have p squared minus 2p equals 3. I could move the 3 to the left hand side, and then I have, I could move the 3 rather to the left hand side, and I have p squared minus 2p plus 3 becomes minus 3 equals 0. This is a quadratic equation already, we know. So we could solve by factorization method. Here we could have p squared, replacing minus 2p with minus 3p plus p, then minus 3 equals 0. Then we are going to factorize now. P is common here, picking the first 2 here, p is common, open brackets. So since p is common, pick the HCF of p square and p, HCF of p square and p, you have p, or if HCF of the whole terms, first and second is p, then p squared divided by p, you have p, minus divided by plus minus, p cancels p, you have 3 here, close your bracket. Then here, my HCF will be 1. So you're writing plus 1. Open bracket, 1 in P, CFP, minus divided by plus is minus. 3 divided by 1 is 3, then equals 0. And P minus 3 is common again, refactorize again. You have P minus 3, and you have P plus 1, everything equals 0. And of course, we know that if this times this is 0, is either P minus 3 is 0 or P plus 1 is 0. Solving this, you have P equals 3, and this you have P equals minus 1. But remember that we, at the initial stage, we made P to be, or we made log x base 2 to be P. So we are bringing this back. So for P, I'm going to replace the P now with log x base 2. So replacing P here with log x base 2 equals 3. And also here to log x base 2 equals minus 1. Then of course, simplifying this, 2 raised to the power 3 must be equal to x. So you say x equals 2 raised to the power 3, and 3 raised to the power 3 is 8. So you say x equals 8 for this one. Then here, 2 raised to the power minus 1 is x. So you say x equals 2 raised to the power minus 1. And of course, we know that x now, 2 raised to the power minus 1 is 1 over 2. So these are our two values that will satisfy that particular equation. So that's it, very simple.